So these words are probably brand new for you guys. Inscribed and circumscribed. Circumscribed. With your mics off at home, practice saying those out loud. Take a few moments right now and say inscribed. Just try to copy me. Circumscribed. Just practice using that language for me, okay? You don't have to turn on your mic. Inscribed and circumscribed. Okay? Today, I wanted to cover the definition of what these words mean. It applies to circles, inscribed circles or circumscribed circles, but we might see some other flat shapes being inscribed or circumscribed as well. So we'll talk about what those mean. And then we're going to look at some theorems about these specific scenarios. So circles inscribed in triangles, circles circumscribed in about triangles or around a triangle. And the last specific one we'll see is quadrilaterals. Quadrilaterals inscribed in circles. That's our plan for today. Get your notes out. Get ready. Today is going to be kind of note heavy. I don't want to make it that way, but I want to cover these three topics. We're going to do a little example and a demonstration for each one. And then you should be ready to rock and roll on your mastery test. So get your paper ready. Let's go. Okay. Okay, so inscribed circle. Look at the beginning of this word inscribed. The prefix is in. So that's kind of your clue that it has to do with in or inside. So an inscribed circle is a circle that's inside of another shape. The circle here is inside the triangle. So we call this an inscribed circle in a triangle. Now, I should also say that it's important that it's not just inside, right? It's the sides of the triangle are each intersecting the circle at one spot, kind of like a tangent line. We talked about tangents last week, but it's inside instead of going through on the outside. So the inscribed circle in a triangle So circle is intersecting the triangle at one point on each side. Now, for our next word, circumscribed, I'm going to wait a minute if people are writing. For our next word, circumscribed, you might think, okay, if inscribed means the circle is on the inside of some other item or figure, then circumscribed is the opposite, and you would be correct. Circumscribed, it doesn't say outscribed, but it's basically outscribed. So this means that our circle is on the outside. It sounds like the beginning of circumference, right? The prefix is the same. Circumnavigate. So it basically means all the way around. Like Manaya pointed out yesterday, circumference means all the way around. So this is our clue that this one is outside. So a circumscribed circle is outside of the other figure. Let's say we have our randomly made triangle and we have a perfect circle, and I'm going to botch this, so bear with me. Here's my perfect circle. And it's intersecting the vertices, not the sides. So here we have a circumscribed circle. So notice that the circle intersects each vertice or vertex of the triangle. Intersects each vertex of the triangle. So that's what we're dealing with today, is inscribed circles and circumscribed circles. So in a moment, I'm going to show you how to make both of these. We're not going to do it by hand. I'm going to use GeoGebra. So that way you can try this at home too and compare the two different types of circles, the inscribed or circumscribed. Not only do I want you to know how to make them, but then there's some theorems or rules that apply when you're dealing with inscribed or circumscribed. So we'll look at those too. And at the end of today, we're going to throw in quadrilaterals inscribed in a circle. Any questions so far on the last two slides? Inscribed or circumscribed circles? No. Okay. So like I've said, for both inscribed and circumscribed circles, there are useful theorems using either the angles or the sides of the triangles. So let's talk about circle inscribed in a triangle first. Circle inside the triangle, basically. So we have some random triangle here, and there's a circle that is adjacent and intersects each side at just one place. Now, I'm just drawing this freehand, so it might be a little off. And here's our first theorem. The perpendicular distance from the center of the circle to each side of the triangle is the same. Okay, in yellow, let's look and see what that theorem is saying. The perpendicular distance from the center of the circle to each side. So if I look at my center, my yellow point, and I want to draw a perpendicular distance to the side below it, the side of the triangle. Let's say I construct that perfectly, and that's perpendicular. And then I make another one here, and it's perpendicular. And I do one on the right as well. This theorem is saying that that perpendicular distance is the same number for all three of those. Does anyone want to, does anyone notice that yellow line or yellow lines I just drew in there? Does that stand for like a common or commonly used part of a circle? Something that we saw yesterday and last week? The yellow line in the circle. Do you recognize what that like represents? What's the distance from a center of a circle out to the edge? What's that called again? Anyone remember? The length from the center to the outside of the circle, to the edge.
You're talking about the vertex?
You said vertex?
Radius, my bad.
Radius, yeah. Maybe my question wasn't very clear. Aaron, thank you for jumping in. Yeah, the radius. Basically, all circles, we use the radius pretty frequently. And that's what I was hoping you would see here. This theorem looks long and it looks confusing. What it's basically saying is the radii, the radiuses of an inscribed circle are all going to be the same. Obviously, all radius for the circle is the same. And That means if we need to construct this situation with an inscribed circle, we can do it going into it knowing that, okay, if I can make a circle inside of this triangle, well, then this spot here, I'll just make some X's, and this spot here, and this spot here will all be on my circle, and they'll all be equal distance to the center. It's basically because they're all radii, the radiuses. This distance is the circle's radius. So it's what is the same thing on this circle? It's the perpendicular distance from the center to each side of the triangle. Okay. This might seem kind of like obvious about it being the radius, but I wanted to point it out. All right. So make sure to have this copied down. The perpendicular distance from the center to each side of the triangle is the same because it is the circle's radius. Okay, now we're going to look at how to do it. How to inscribe a circle in a triangle. These are the basic steps. I'm going to just kind of draw a sketch, but then I want to show you how to do it in GeoGebra. And you know what? You're all on computers, I believe. So I'd like you all to try this with me. Let's do that. And then when we're done, you could show me if you were able to get it. And if you weren't, I want to know what stage you got to. Okay, so I'm going to show you guys first. And then I want you to try inscribing a circle at home as well on GeoGebra. Here's the basic idea. We're going to make a triangle. So imagine if we just randomly made a triangle. So you start with that. And then our long-term goal is we want to put the circle in the right place at the right size. So we're fitting a circle to be inscribed in our randomly made triangle. This is the key step in how to inscribe a circle. It starts by bisecting each angle. So in GeoGebra, it's really easy. We're going to just use the little tool that allows us to click on the two sides that make the angle. So I'm going to click on like this side and then click on this side after using the tool, and it will automatically make a line that is bisecting that angle, cutting it in half. And then we're going to click the tool again and click on this side, and it'll bisect the top angle. And then you would do the same thing for the last one, and it'll cut it in half. The angle bisector lines meet at the center of the circle. So the reason we're making the bisecting angles of the triangle is because they all meet at a certain point. And that special point right here is where your circle can go to be an inscribed circle. So prepare yourself. First, I want you to just watch me do it. I'm going to do it in GeoGebra. And then I want you guys to try it at home. And I want to see your work. You can just quickly, when you're done, when you're ready, you can share your screen and show me what you got. Or if you're not able to do it, I want to know what stage you're at, what you were able to do. So here's the website we're going to, geogebra.org. Type that into your browser, GeoGebra. And then you click on Start Calculator. Don't sign in, don't make an account, just click on the blue button, Start Calculator. You'll have a screen like this. To use it, we're going to click on the tools on the left side. Tools. Don't click on algebra. That one we don't want today. Tools. To make this, we're going to just randomly make a triangle. So we're going to click on point at the top. And you can click anywhere you want on the screen and make points. I'm going to click on like the grid lines. Not just like in between them, but try to click on those grid lines. And I'm going to make it kind of a skewed looking triangle, not a perfect looking one. And once you have 3 points, you scroll down in your tools and we look for the header that says lines. And you see there you can make segments, lines, rays, vectors. We're going to click on segments. And then you just select 2 points you just made and it makes a segment in between them. Super easy. So now I've got my triangle. So now to do the angle bisectors, if we look up here in the construct tools, construct, one of them is called angle bisector. So then to use it, all you got to do is click on the 2 like lines that are creating the angle. Boom, boom. And then I do it again. And I do it a third time for the top 2 lines. So now it looks a little more busy, but you can still see the original triangle in the middle. I'm going to zoom in. And see how they're all intersecting at that same point? I'm going to go ahead and throw another point right at that intersection. And now I can make my circle. So scroll down in your tools, and there's circle with center. And it says select center point and then a point on the circle. So I'm going to select my D point. And then if you see me doing this, you just move your cursor out and basically click when you want it to stop. I'm going to try to show it being right at the intersection on my triangles. Boom. So there is still a little bit of estimating going on because I didn't actually make a point for it to intersect with on the triangle. But here's my triangle created randomly, and I bisected all the angles, and then I made a circle at that special center, the in center, and that's it. So I'm going to stop sharing. I want each of you to go to GeoGebra. And you know what I'm going to do? I will go ahead and share again. I'm going to share again, and I'll go back to my instructions. I only want to spend maybe 5 minutes on this, and it's 10:25 right now. So first, I'd like you to do this. Go to GeoGebra, click on Start Calculator, click on Tools on the left, and then make a triangle. Let's start by just doing this in step by step. So make a triangle and then show me your triangle. And then if you have questions, if you need a hint at how to continue, just tell me. On my screen, I've got our basic instructions. Make a triangle, bisect each angle, and then make a circle where they intersect.
I already made a triangle.
Dang, Aaron. Okay. Would you mind sharing your screen and showing me really quick? And I'm going to use yours as a side example really quick, if that's cool, just to get you and other folks onto the next step.
You can see it.
It's still loading. Perfect. Looks great. Don't stop sharing yet. Now, Aaron, your next step after making your triangle is to use the angle bisector tool on the left. Do you see that one? Angle bisector. It's under the heading construct. Like the bigger writings that are there, construct.
Oh, construct.
Yeah, you had it up. It's kind of in the center of your screen right now. There we go. Angle bisector. Very good. So that's going to cut the angle right down the middle. And when you click on these tools, you've noticed, David, that it gives you a little pop-up with how to use the tool. So it says to just select 2 lines. So go ahead and click on 2 of the lines of your triangle. Perfect. So you've bisected the angle at A. And now I want you can stop sharing now, Aaron. You're going to bisect the other 2 sides as well. Bisect the C and the B. And yes, it's getting messy, but when you're done, all three of those bisector lines are meeting where your circle should go, basically. Okay, how are the rest of you doing? Delaney, woohoo! Can I see yours, Delaney?
Yeah, I don't. How do I like share my screen?
In Zoom, at the bottom where you have like your little options and settings, one of them is share screen, and I think it's going to be green. Where you have like stop video, mute, chat, all that stuff. There we go. Dude, very good. So Delaney, this looks terrific. You've got your randomly made triangle. You've got two angles being bisected, and then you have your circle perfectly inscribed. I love it. Now, I'm glad you did it. That you can stop sharing if you want. You didn't do the third angle. Is that a big deal? Actually, not really, because all three of those lines are going to meet at that same intersection where you made it anyways. So the truth is, we don't actually have to do all three angles. However, it is important that that we're able to not that you, but like in general in math, that it works that all three meet at the same spot. However, it always will. Those angle bisectors will always meet at the same location. So it worked out. Very good.
Thank you.
Thank you for sharing. Manaya, how's yours coming?
Not good at all because I'm trying to figure out how to work this site and how y'all got triangles and all that.
Okay. There's nothing to be worried about. Share your screen with me, please. We're gonna do it real quick together. You'll be done in no time.
Okay, hold on.
You got this.
Can you see it?
It's loading, but yeah, it's almost done. Cool. So you're all set. Click on over on your tools. We're going to be using those going up and down a little bit. Scroll up, and we're going to use point. It's at the top of your tools.
Ooh, point.
There we go. So go ahead and pick 3 points. Just click, click, click out on the screen and make your triangle.
Click. Click.
Wherever you like. Perfect. Now, on the tools on the left, scroll down. You're going to click on segment, and it's under like the line heading. So different kinds of lines, and one of them is segment. You're going to make a segment. Click on those points for me. A to B, B to C, C to A. Sweet. Okay. Now look at the tools on the left. You've got angle bisector. It's right above the lines that you just used. There you go. Click on the 2 lines or 2 sides of a triangle. So like right around C, click on the line above it and below it. Okay, now I think you gotta basically click on the tool again. So click on angle bisector. And now try to click on the CA segment, segment CA, the line between C and A, not the axis.
I don't know why I'm doing it.
So I think every time you like click on the not a line segment, it's basically resetting.
Oh, there we go. There we go.
Okay, you got it. No, wait, hang on. That thing's not, something's not right. Okay, it's okay. Up at the top left of like your graph screen, Manaya, see the little back or undo button? There's a little back arrow. Click that for me. Okay, cool. So let's try it again. Click on the angle bisector.
Okay.
Okay, now don't click down yet. You want to be on that CA segment. See the side of the triangle that has the C and the A?
Yeah.
Click on that line, the black line, not the point, the line. You got this. And then click on CB below it, that lower one. And it'll highlight as well.
Okay.
Well, okay, that's the right idea, but you clicked on some random point inside the triangle, not on CB. Do you see how when you clicked on CA, it kind of like highlighted and got a little thicker?
Yeah.
Because I saw that. You did that one correctly, but then I think you somehow managed to click on like some So can I show you one more time?
Yeah.
Okay, it's all good. Thank you for trying and for showing me. I want you to do this, and then we'll be oops, I'm going to like close the meeting on accident. Nope. And I didn't check in with Antonio and Andrew. So you guys, can you tell me how you're doing? Okay. So Manaya and Tony and Andrew. I click on my points. Very nice. Make it a triangle with some segments. Very nice. And now for this tricky angle bisector. Manaya, it might be helpful if we zoom in on yours. If we're zoomed out far, it might make it more difficult to click on the lines we want. So on mine, I'm going to zoom this puppy in. I'm going to zoom it in, make my triangle bigger. That might be helpful. And now to use angle bisector, we click on the tool. And we have to click on 2 lines or else it's going to kind of like undo and reset. So I click on my left top line like you were doing. Then I click on the next line below it. And it's going to cut angle B right in half. So this little angle on the top is equal to the angle below it. Manaya, can you try that again for me? You don't have to share screen, but just try it and let me know what it looks like.
Okay, I think I did B right.
Sweet. And inside the triangle, you're going to get your lines like cutting through the angle bisectors. And if you do all 3 angles, you'll have 3 lines going through, and they're all going to be meeting right at the same point inside the triangle somewhere.
I think I did it right.
Can I see your screen again? Do you mind?
Me?
Yes, you.
All right.
Great.
Go back to... Where's the code? Oh, no, I found it.
Antonio, you were saying you had an issue also, but it seemed like something made sense or was fixed. Great. Oh, Manaya, that looks good. Your B is correct. I don't know what's going on with the one in C. I can't tell why it's doing that. But I think it looks like you're using the axis. I don't know how that's happening, but it's using like the x-axis instead of like the bottom side of the triangle. I think if you zoom in, it would probably be easier to click on the correct lines. But anyways.
I did these ones zoomed in. I just zoomed out when I shared my screen.
For sure.
That's how I got B correct.
Try it. Okay, I'm going to stop having you share, and I'm going to move on. But I want you to try to do the angle bisector for A as well, okay? Okay. All right. Antonio and Andrew, I didn't ask to see your guys' screens. Andrew, how did yours go? Did you get it finished? Did you have any questions? You're on the phone. Okay. All right, guys. I want to move on to circumscribe because I took a little longer than I meant to. So Delaney and Aaron, thanks for waiting. Here we go. Let's move on to circumscribe circles. Okay. Yes, Andrew, please send me a picture later. And even if we don't get it all the way done, that's okay. I just want to see you guys trying. And I would like to help you work out how to use GeoGebra too. Maybe not just right now at this point, but yeah, at another time if you guys would like to do that. Manaya, can I mute you really quick? It's all good. Okay, so we just did this student practice. Okay, so these are the theorems again. So now for our circle, circumscribed about a triangle, we have our randomly made triangle to start. And then if we can find the right way to perfectly have a circle that goes through those 3 vertices, something like this, See how the circle's on the outside? So here our circle is circumscribed. I know that sounds like circumcised, but that's not, not even related. Circumscribed, like written, scribed. So why is this useful? The distance from the center of this kind of circle, so let's say the center is right here, to each vertex of the triangle is the same. So not the distance to the sides. And if you look at this diagram with me, even though I just eyeballed it and estimated it, it doesn't even look like the distance from the center to the sides is the same. See how if I was just thinking to the sides, these are obviously all different than each other, right? There's that tiny little distance I just drew, and then the two that are closer together. So it's not the sides, but this time it is the vertices that is the same. And just like Aaron pointed out with the last one, it's the radius of the circle. It might be obvious to you, it might not be. It's like, of course it's the radius, because from the center to the edge is the radius. So if the vertices are on the circle's edge, then that's the radius again. But it's changing what is like the same. Oh, Keegan's here. So this time it's the distance from the center to the vertex of the triangle. And again, those are the radii. That's why they're the same. That's why they're equal, because they're basically the radius of the circle. So this looks a lot like the last set of theorems we had for inscribed. But if you've written these down, you should be noticing it's not the same exact words because they're using different parts. Although, yes, they do sound the same. They sound very similar to each other. Now, how do we make a circumscribed circle? It's similar to what we just did. We make our random triangle, but this time we're using the perpendicular bisectors for each side. So we're not bisecting the angles of the triangle, we're bisecting the sides themselves perpendicularly. And these lines meet at the center of the circumscribed circle. Because of time, I'm going to go ahead and run through this one. I want to show you how to do it. I should have we'll come back to that. I'll have this whole slide up later, so you can practice this again on your own time, slower, without the pressure of trying to have it done fast. It's not my intention to make anyone feeling pressured, but I do want to show you how to do it, and I would like you to try it as well. So if you're going to send me a picture of your other one or either of these, send me both, please. Maybe I should make that today's homework, is just to try both of these on your own later if you can't right now, and then send me a picture. So back in GeoGebra, I'm going to delete all my old stuff. We're going to randomly make a triangle like we did last time. Bing, bang, boom. And connect them. This is like an isosceles triangle I just made without even trying to. If you want to make your triangle, bigger, weirder looking, not like, maybe I should move this. Yeah, that'll work. So if I clicked on move and selected one of the vertices, you can like adjust things. So I'm going to make it a kind of funkier looking. Now what we're going to do is perpendicularly bisect each side. So there's a tool for that. All you got to do is scroll down and check it out. Under construct, there's perpendicular bisector. Select 2 points or one segment. All you got to do is click on the lines one at a time. So look at my picture. I'm going to click on segment BC, and it's drawn a line. It's cutting BC in half, and it's perpendicular. Now I'm going to click on my tool and side AC. I'm going to click on my tool and side AB. I'm going to zoom it out. A little less messy than the last picture, right? Notice that they're meeting outside of the triangle. That's okay. Often with circumscribed circles, they're outside of the triangles. So now to make your circle, you click on the circle tool, circle with center, click where they're meeting, and then you kind of just drag that puppy out until you hit one of the vertices. And if you've done it right, it should line up with all three vertices. See, as soon as I drag it to the C vertex, it's hitting A and B as well. Woohoo! So here's a circumscribed circle about this randomly made triangle. And since now you see the circle, and if we imagine a radius, we could draw one in, but I don't want to make it too busy. I'll draw in a radius from D to C. And you can see the radius from D to B. And if we draw one in from D to A, well, obviously those are all the same length because they're all radii. So I think even if you don't do a construction of this, like in GeoGebra or on paper, just drawing a picture of an inscribed circle or a circumscribed circle can be helpful. If you need to remember, like, what is the equal part? Is it to the sides that's equal, or is it to the vertices that's equal? Any questions on this circumscribed circle in GeoGebra? Process is the same, but we're not doing angle bisectors. We're doing perpendicular bisectors of sides.
Were we supposed to do this?
I do want you to practice, but if you don't get it done right now, it's okay. I think I'm going to make the part of today's homework to try doing each of these at home and send me a picture.
All right.
Okay? So I do want to get you guys doing some geometry on paper, even if we're not like together. So this is probably the best we'll do, is doing it in GeoGebra. All these instructions will be posted, to our Google Classroom. So you can see this again later, take time with it. Okay, we do have a third one I want to show you. Quadrilateral inscribed in a circle. This one's a little different because we're not using a triangle, we're using a quadrilateral. Quad, you know what quad means. It refers to a number, right? 4. Quadrilateral is a 4-sided shape. There's lots of different types. So we're basically talking about a quadrilateral 4-sided polygon. It says it's inscribed inside the circle. So what would that look like? We have our nice circle. We've got a 4-sided shape. It could be a square, or it could be like really skewed looking. But here's the idea. Here's just what one example might look like of a 4-sided shape, 4-sided polygon, inscribed. So that means each vertex is touching or on the circle. It's not cutting through the sides, right? It's cutting through just the vertex. That's what makes it inscribed or circumscribed. Now we have one or two theorems that we can use for this scenario too. And I have it right underneath there. The center of the circle is equidistant to every vertex. I'll redo my drawing here. And this can only happen when the opposite interior angles are supplementary. So I'm going to draw the picture again. We need to talk about some of this language. So if we have a circle 4-sided, okay. The center of the circle, let's throw that in there, is equidistant to every vertex. Why is that? Look from the center out to those 4 vertices I made, A, B, C, and D. Well, again, just like we saw with the others, it's basically a radius. So if you've got this scenario with a quadrilateral inscribed in a circle. The center to the 4 points are all radii, so therefore they're all equidistant. They're all the same number, measure. And this one's important here. This can only happen when opposite interior angles are supplementary. It's been a while since we've used some of this language. Opposite interior angles are supplementary. Supplementary, what does this mean? It means two angles add to 180, or their sum is 180 degrees. Opposite interior. So opposite means across from each other. So angle A plus angle C. In this diagram, they're opposite angles. They add to 180. And B and D are opposite. And these add to 180. They don't equal each other. They add to 180. They're supplementary. And check this out. Since they both add, these two pairs, these opposite pairs, add to 180, well, 180 is the same as itself, right? So that means A plus C is equal to D plus B, the angle measures. So we will see some like algebra problems with quadrilaterals, because if I know what, let's say we knew angle A was like 50 degrees. Well, I know that A plus C is 180. So now I should be able to solve for angle C. It's 180, take away 50. That makes C 130 degrees. So if you know one of these angles, we should be able to find the other because they sum to 180. When the polygon is inscribed in a circle, it's possible to have quadrilaterals that aren't inscribed in circles. I want to just really quick show you what I mean. So let's say you have a circle, and I can just make a quadrilateral. Here's three of them, points. So it looks like I'm doing good and I've got it inscribed, but let's say my next point was like right here. So far I've got three on one circle, but I can't make a circle that uses all three of those and that last one, the last vertex. So it's very possible to have quadrilaterals that are not inscribable inside of a circle, and in which case their opposite interiors don't necessarily add up to 180. But when you do, when the quadrilateral is inscribed in a circle, that means opposite interior angles are supplementary. Okay, I guess we can go ahead and do this. Here's something I want you to take a picture of or write down. This is one problem from the mastery test that I wanted to just give to you all in case you get it in your mastery test. Because we're not able to do these like paper constructions at home, and I'm having you do work on GeoGebra instead to do your constructions. Go ahead and take a picture of this and use it if you need it while you're doing your mastery test. I think this one would be more fair to give you if we were able to practice doing constructions with paper and pencil and compasses. But since we're not doing that this year, go ahead and have this one. Okay. We've got 10 minutes left. Actually, about five or 8 minutes left. Now, we didn't get to many examples. Homework for Wednesday, the 23rd. Homework is to try doing both of those. I know two of you already showed me. doing the inscribed circle. But I'd like all of you to just take a moment today. It shouldn't take too long to do the inscribed circle and the circumscribed circle in a randomly made triangle of your own. In GeoGebra. Send me a picture through email or Remind or your Google chat. Lots of options. Or you could even upload it into the Google Classroom. Send me a screenshot. Or if you need to do it on your phone, that's cool too. Like send a picture on the phone. But maybe a screenshot will work. Send a screenshot or a picture. If you can't figure it out, what are you going to do? Just give up? Or can you message Josiah and say, hey, I'm trying to use GeoGebra. I don't know how to X, or I don't know how to make a triangle. I don't know how to do the angle bisector. And I'm going to see that message and write back to you and try to help and get you going. Okay, maybe we can have a quick phone call, or we can just text, whatever's best. I want to use these in your work samples. I want to see some actual geometry from you guys at home. Even though it's digital, it's cool. I want to see you making these yourself. So send me these pictures, and I'm going to include it in your guys' work samples. And it's your homework assignment for today and mastery test. It's a lot. But this unit's almost done. So mastery test called inscribed and circumscribed circles. Problems in the mastery test are all going to use those 3 theorems that we looked at together in class. Okay. This making the inscribed and circumscribed circles shouldn't take too long. Just play around with it, and if you make a mistake, you can always like undo in GeoGebra and then just try it again. You know what, Antonio? I did not. I'm sorry about that. Thank you for reminding me. I'm going to write it down here. We'll talk to Megan and see if we can get it all figured out. Is Andrew also with Megan? Or do you have a different teacher, Andrew? Oh, I see. You have someone else. Okay, I'm just confused because Megan has other students in my classes. And it's the same for everybody. So I'll talk to her. Thank you for reminding me.